Good morning. Thank you all for being here, for joining us and taking the time out of your day to listen to us. My name is Nate Langston. I'm a journalist and a global technology editor at Bloomberg. Much more interesting, though, is the gentleman to my left, who is Sean Edwards and is the Chief Technology Officer of Bloomberg overall. And Sean's been with the company for about 20 years, which is more than twice as long as I've been there. And what I think is very interesting is Sean's team essentially sets the direction that all of technology at Bloomberg takes. And in preparation for this session, I have learned an enormous amount about my own employer. And so it's my hope that we can leave you with some takeaways that I myself have learned during preparation. So let's start at the top. I mean, obviously, most modern financial firms and governments and agencies have been using AI in some form for many years, but generative AI in particular, as it relates to finance, is something new and special. So talk to us about your experience with that.
Yeah, well, first, you're absolutely right. Machine learning and AI in finance has been around for a long time. Bloomberg has been using machine learning at scale for over 15 years. Today, we use AI throughout Bloomberg. We have thousands of machine learning models running in production every day. We use it to analyze and process the massive amount of data that we ingest every single day. Just as a data point for the scale, we ingest over 2.5 million documents every day. We have multiple machine learning models analyzing every document. Some that are looking at information extracting and from a filing and taking out the earnings or the tax numbers. Others that are doing sentiment analysis. Others yet still looking at interesting signals like market impact. We use AI to generate new signals and create new insights out of what the world is doing. And we use AI directly in the terminal, our flagship product. Our users are touching AI every day in some of the most used features and functions in the terminal. So AI has been around for a long time. We run AI at scale, and most of what we care about is things that are very accurate and very fast. We usually have to process data in terms of tens of milliseconds, hundreds of milliseconds, and it has to be incredibly accurate. Now, generative AI is a very different thing. It has different properties, and there's different trade-offs with it. And so there's kind of, I like to think about it as differences in three kind of spaces, right? One is generative AI is more general. The models can do sentiment right out of the box. You can ask it to do information extraction. Not as accurate and not as fast, but it's very useful. The second is that these models have an incredibly broad understanding of the world. They do know about Shakespeare, and they also know about, you can teach it about finance, and it does know a lot about the world. That's different from our existing models. It doesn't make sense to ask a model to do something, that sentiment model to do something else. And you also can't ask it about Shakespeare or anything else. But I think the third property, the third difference is what's most exciting, and Jensen Huang mentioned it, which is these models are accessible. All of our existing models, or the traditional models, you need an engineer, an AI expert to code to it using Python or CUDA. And now we have AI models that you just speak to it in human language. It's going to be a game changer about how we develop and who's developing our systems. So I'm extremely bullish. I think it's going to help us solve, and it already is helping us solve problems that we couldn't solve before, but there are caveats.
Yeah. I mean, when we're talking about Gen AI here, we're not talking about a traditional chatbot interface. This isn't, please tell me exactly what I should invest in, or please tell me exactly the state of these bonds.
How do I make money tomorrow? Yeah.
Yeah, I mean, that would be great, and you should maybe build that. That would be fantastic, but it's not what you're doing, right? So what is a real world example of the way that is being used right now, and how is that benefited by the domain expertise?
Yeah. So, well, first, that when you think about generative AI and it's the kind of the limitations that it has, I think we first have to talk about some of the caveats that I just mentioned. In the future, I think we're going to see some amazing capabilities. So maybe I'll start there.
Yeah, take us
In the
5
future-
years from now.
Yeah, I think that's I don't know what's going to happen 5 years from now. So I do think that we can talk about realistically, what are the steps? What are the kinds of problems we can solve at every stage? Today, I think generative AI is already helping us make information more liquid. It's going to help us make information accessible. You can build natural language interfaces, human interfaces, into your massive corpus of documents and ask questions, ad hoc questions, and retrieve information. You can ask questions about your structured data. You can ask questions through these language interfaces, which I think we just couldn't do before. And you can build assistants today. And you're starting to see the emergence of tutors. Tutors not just for children, but for your own workers, whether they're in a government or in finance. These assistants actually help our employees be better. So I think the next step is where you start having truly intelligent assistants. Those assistants would be something different than it's achievable today. Today, you can solve kind of the first level type of problem. Let me ask you a question, let me interrogate information. Intelligent assistants will be able to think about a problem like we do, like a big problem, and break it down into steps, where the output and the decision or the outcome of one step actually tells you what the next step should be. We're not there yet. But these kind of larger type of system two type of questions would be, I think, the next step. And then the third is fully autonomous systems. And I'll let others speak about that kind of place.
Yeah. There's been a lot of hype, I think it's fair to say, over the last 12 months in particular, around generative AI. How do you avoid falling into the trap of building something because it seems buzzy and popular? And how do people here take that away and apply it in a government environment?
So although my title is Chief Technology Officer, I am very adverse about following the fads in the tech industry. I joke about with people and say half my job is keeping the silly technology out of my company. I don't think this is one of them, but we do have to understand what's hype and what's real. When we look at generative AI, you have to understand that today, and I'm talking about like what you can use today, whether it's the open source models or the models that you get from Google or OpenAI. Underlying these systems like ChatGPT, there's a large language model. The model has a statistical understanding of language. It does not have a ground truth. And so they often will tell you something incredibly convincing, but is wrong. So they don't really have a great view of the world. And in finance and in government, accuracy is paramount. And so you have to work really hard today to take a model, a large language model, and make sure it's telling the truth. It's not simple. The second thing is, in finance, we care a lot about history. We care a lot about what's happened over time. And these models actually don't understand the temporal relationships between the things that it learned. And finally, irrespective of all the hype, these models actually don't reason very well. They're not actually understanding logical concepts. They don't do math well. So you put this all together and say, how do you use that for finance? And it's challenging. It's challenging.
How do you approach data provenance and making sure that people know where the answers that they're getting, like where they originate? What is the source of that information?
Yeah, well, first of all, that's what we do. That's what Bloomberg does every day. For 40 years, we have been collecting a massive amount of high-value data, highly valuable data, and we've been cataloging it and really, truly understanding what's useful, what's not, and we keep track of all that provenance. And with the way we're thinking about using generative AI today is our philosophy is that generative AI is just an ingredient, just one ingredient that we're going to mix with all of our trusted sources of information, our databases, those trusted documents, our analytics that we've built, and embed it into the workflows that we currently have. We do not want to allow the large language model to give the answer to our customers because of all those problems that we just mentioned. But we can use it to understand what the customer is asking. We can use it to get to that, to the trusted source of information. And so when you think about how we're using generative AI, we really think about it as a whole system. The large language model is one part. There's many different interesting aspects that, or products that we can build that we already are building today. In fact, we just released our first generative AI-based product just last month. And it was an earnings transcript summarization. So the problem is that you have analysts who are covering companies, and during earnings season, there's lots of these earnings calls where the CEO or CFO are talking about really material aspects of a company. Analysts have to pour through these, have to either listen on the call, they have to read the transcripts, and it's daunting. And it's just one example of the bigger problem we're trying to solve. There's so much information, human beings cannot keep up with it. So we need to use AI to help humans deal with this information, right? And so we did something really novel. We worked with our domain experts, our analysts, and we said, what are the questions you would ask that transcript? I know that sounds funny, but that's how you have to think about it. And we were able to create answers, AI-generated answers, within all these different topics about guidance and liability and all sorts of other topics. And the way we think about this is we always want to keep the user in the driver's seat. These are assistants. We are not automating everything away. And so when you look at the application, you have the transcript in front of the user, and on the side, you have all these bulleted points of summaries. Those are AI generated. But the user can just click on any one bullet point, and we highlight, we scroll to the paragraphs, and we highlight the paragraphs that were used to generate that bullet point. Transparency and attribution are fundamental to building these systems today, and I think it's going to be true in government as well. You need to show your work. We need to show all the steps that went into synthesizing the answer. We need to show all the steps to our users, whether they're internal government workers or in finance or to citizens or our clients. We have to show them this is really what happened. And yes, this is a great tool, but let me show you all the work. That builds trust. And you get directly to that source document, and they can look at the provenance. They can look and interrogate things. And so this is our philosophy, how we're doing this. We have a number of really exciting, very powerful tools that we're in, and features and functionality that's coming out in the next few months throughout this whole year. And it really is changing the nature of how our customers interact with this massive amounts of data. This transcript summarization is just the beginning. What's coming soon is the ability to ask a symbolic question, a thematic question.
What would an example of that be?
Sure. I'm an analyst today. If I have a big question, I have to go to our search engine and break it down into keywords. We all know how to do that. But the analyst is really thinking of something high level, like, tell me about the slowdown in production of batteries in China and how it's going to affect Ford EVs. That's their question. They often have to go and search through many, many different documents and pull that together. But now you just ask the Bloomberg terminal and you get all the source documents. We look through millions of documents and we find the 6 paragraphs and the 4 documents that are best answer that question. We show them that. We show them the paragraphs that highlight it. We also synthesize a summary for them. So this is a combination of not just large language models, but other AI technology, like dense vector search engines and many others. It's a whole collection of services and components that go into building these systems. Really soon, my team is working on, I see it working, the ability to ask in human language a question to all of our structured data, our massive amounts of databases that we have on companies and macro information about the economy and commodities, and just be able to ask the question without having to be an expert in coding. We show you the steps. We show you the formula that it generates. We show you everything, but we can just instantly give you that answer. This is a game changer. I think Jensen Huang said it best. This is going to allow anybody to be a programmer. I would like to say it's just going to make every analyst and portfolio manager and trader just be better at their job.
I've heard people say that the next great programming language is English as it relates to AI, but I also think there's a lot more to unpack there. I'm conscious of time, and I'd really like to give people some concrete tips for next steps. You know, if they want to act on things that you've said today. How exactly should, say, a government agency start to recreate in their own fields, with their own domain expertise and their own languages, what you have been talking about having done with finance?
Okay, well, first and foremost, you should just start. You should start, but start very carefully. I highly suggest the first step in any government agency is to first start collecting and cataloging and understanding the data that you have. That's the value you have. It's that data, and understanding that data is incredibly important. So collecting and cataloging and processing that data to get it ready is actually a pretty hard step. The second thing you have to think about is it's not just collecting the documents and the data, it's actually collecting the experts who truly understand those documents and that data that you have. You need the people to understand that registration form and what it means in all those fields and exactly what those fields mean, and all that language and understand what that means, how it's evolved over time, whether it's filings or other aspects that you might have in your government. Those are the people who are going to be driving the innovation. I know we tend to think of, largely PhDs in computer science and AI experts, but what we found is that you have to build these cross-domain teams, these cross-functional teams, and it's the experts in the data that are truly making these systems successful.
And they're working hand in hand.
Hand in hand, on the whiteboard, talking to experimenting. But those domain experts are incredibly valuable, and you have to start gathering them and starting to work with them. Next, you have to work together in that team, and this is where the domain experts play a big role. What's success look like? How do I test my system? It's actually quite easy to start getting results. This is not about just getting a bunch of documents and throwing it at an LLM and asking it questions. You're going to get results, right? But that's not going to be the good results that you want, right? So you have to spend the time to actually understand what's your success criteria. What am I actually trying to achieve, and how am I going to verify that? And as I evolve my system, how am I going to continue to make sure that the system is correct? The other aspect is really understanding the biases in your data, right? That's a huge one. It probably needs a whole session by itself.
I was going to say, in 1 minute, can you just tell us how exactly we eliminate bias from data sets?
I wish I was that good and that fast. There's a lot of thinking that goes into play here. Because of all these challenges, my recommendation, and just like we did it, is start small, start careful. Start in a place that's not the most mission critical aspect of your government or in your company. Build a system that maybe it's just for internal users to make them better, and carefully monitor it. Start small, start really understanding how all this technology works, but really embrace your data.
And just to finish, how do you advise people manage the expectations of their key stakeholders? How do you make sure that they can push back and say, this is realistic and this isn't realistic? And I heard Sean Edwards talk about this at the World Government Summit, so it's absolutely accurate.
Yeah, I spend a lot of my day explaining, what's feasible, what's not feasible, at least this step. And now this is an incredibly fast-moving place. 6 months from now, I think we're going to be able to solve even more problems, and we're going to have better tools, et cetera. But I think it's really about articulating this space.
Okay, well, we're bang out of time now, so I'd like to thank everybody for taking the time to join us, and of course, thank you to Sean Edwards.
Thank you.